this. All right, so we talked about the product rule. The product rule was kind of simple, right? I mean, fairly simple. You had u, v, you take the derivative of that, you had u prime v plus u v prime, right? So there really isn't anything to kind of screw up because you're just taking one of the derivatives, multiplying the regular, and then take the other one derivative of the other one and multiplying it by the regular, right? And you can actually swap them. It doesn't matter, they're the same, okay? That's okay, so that's pretty simple. Now the question is, what happens when you're trying to take the quotient? Okay, when you take the quotient, this one is just a little iffy. So we're gonna get v squared over vu prime minus uv prime, okay? Now there are several things that can go wrong here, okay? You can forget the square. There's a minus here. You cannot flip these around either now, okay? It has to be in a certain order, okay? So it's the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, okay? So the usual mnemonics for this is what? Is we say, it is v squared minus low d high minus high d low, okay? Low d high minus high d low. Low meaning the denominator, high meaning the numerator. Low d high minus high d low, okay? So the way that most people understand or remember this is low d high minus high d low. Okay? So yes, this is a little tougher than the product rule. The quotient rule is going to be tougher than the product rule. Okay? So let's see if we can use this. So let's see if we can go example number 5 and actually use this. So example number 5 says differentiate the following. X squared minus 1, x squared plus 1. I'm taking the derivative of this. And then support it graphically. Make sure it's the same. Using graphically to prove that it's the same. So, the easiest parts first is the low is going to be squared. And you can take the low d high. So, low d high. So, I'm going to take the derivative of the high. If I take the derivative of x squared minus 1, it's going to be 2x. Minus 1 goes away because it's 0. Minus low d high minus high d low. So I'm going to take the derivative of the low, the denominator. So that's going to be 2x. So I do that, I get 2x cubed plus 2x minus 2x cubed plus 2x over x squared plus 1 squared. This guy goes away. 4x over x squared plus 1 squared. Okay? So that's that. Okay? So, and then we're going to go to page 123, the negative integer powers of x. So we talked about how to differentiate x to the n, right? We said x to the n comes down and we get n minus 1. In other words, x to the n, if I take the derivative of this, I'm going to be x to the n minus 1. All this is saying on rule 7 is that this works also when n is a negative integer. We already talked about we're working on x cubed, x to the 5th, and those type of things, right? But if I want to take the derivative of minus 2, it works the same way. So it's going to be minus 2. The minus 2 comes down. Then I'm going to subtract 1 from here, so it's going to be minus 3. Which means that it is minus 2x cubed. If I had 1 over x, and when I take the derivative of this is the same as x to the minus 1. Taking the derivative of this, minus 1 comes down, so it's minus 1 times x to the minus 2, which is minus 1 over x squared. Okay? So in other words, the n can not only be a positive integer, it can also be a negative integer. Okay? It can't be 0, right? Because x to the 0 is equal to 1. And take the derivative of 1, I get 0, right? Okay, so example number 7. Let's see, using the power rule and with a negative. So let's see if we can do that. Example number 7. Y is equal to x squared plus 3 over 2x, which is the same as, which is going to be 1/2 of x plus 3/2 x to the minus 1. So now I'm going to take the derivative of this, y prime. So if I take the derivative of this, what do I get? 1/2 of x. I take the derivative of that, it becomes what? Just 1/2, right? Take the derivative of this, I'm going to get negative x to the minus 2. So it's going to be 1/2 minus x squared. This is what I'm going to get. Okay? And blah, blah, blah. What else am I supposed to do? Find the tangent at the point. Oh, so I'm supposed to find the tangent line to the curve at point x equals, so the point is going to be 1 and 2. So when x is equal to, so y prime when x is equal to 1 is going to be equal to what? Because x is equal to 1, right? I mean 1/2 minus 3 over 2 minus 1, and it goes to this point, so it's going to be y minus 2 minus 1 x plus 1. And x minus 1, I'm sorry. X minus 1 here. Okay. All right. So that's how that works. Bottom of page or middle of page 124, we can actually take second and third and fourth order derivatives also. In other words, I can start with a certain thing. If I start with x to the fourth plus 3x to the second plus 6x plus 2, and this is y, and I can take the y prime, and that would be what? If I take the derivative of this, I can get 4x to the third plus 6x plus 6. Okay, now I can take the double derivative. I can take the derivative again, which is actually either looks like this, or you can say dy like that. That means a second order derivative of y. Then I'm going to take the derivative of this, right? So I take the derivative of this, I'm going to get 12x squared plus 6. I can go the third. If I take the derivative of this, I'm going to get 24x. 6 goes away. I can actually take another one. Okay, so after the third one, we normally go like this. This kind of becomes kind of repetitive to do 4, and then somebody has to count how many, things there are. So after the fourth, we go like this. We take the derivative of this, we get 24, right? Okay. So example number 8 shows. So example number 8 tells us how to do this, or an example of that. So let's see if we can do that. Example number 8. Example number 8, find the first 4 derivatives of y is equal to x cubed minus 5x squared plus 2. Y prime, I'll take the derivative of this, is going to be 3x squared minus 10x. This guy goes away. The second derivative is becomes 6x minus 10. Third derivative is going to be 6. This guy goes away. The fourth derivative is a derivative of 6, which is 0, right? Because it's a number. Any derivative of a number is going to be equal to 0. So this is how you would just kind of methodically just run it through, right? Example number 9 is the same thing. I'm not going to go over it. So you guys can work on example number 9 on your own. And we are done. We are done with 3.3. So when you do the homework on 3.3, do it well. All right, because I will be asking for questions again on Thursday.